Alright, so we are now on to percentage depreciation, following on from yesterday's videos on percentage appreciation. So if you haven't done that work yet, then before you watch this video, I encourage you to go back and look at the work on appreciation. So this is basically just the opposite. This is about a repeated percentage decrease. So the formula is exactly the same as for appreciation to work out the final value. Now it's important to understand the formula is literally exactly the same. Now I'm going to highlight the multiplying by the multiplier. Often when people think about decreasing, they think they have to divide, but actually what we're going to see is when we multiply, when our multiplier is less than 1, it actually goes down, and we saw that a bit in our work with percentage increase decrease last week. So regardless of whether it's going up or going down, you're always multiplying, and it's just going to be this decimal multiplier which is going to affect whether it increases or decreases. So if you didn't get this formula, copy it down. You should have it already from yesterday or the last lesson's work. And what we are going to do is copy down example 1. So read this with me. We've got a hot air balloon which was drifting along at a height of 16,000 feet. It then developed a leak. So the balloon dropped by 8% every minute after that. And what was the balloon's height after 3 minutes? So we've got 3 factors. Remember, we've got our initial quantity, which you can just write these down with me just now. So our initial quantity, which is the height of the balloon at the start of the question. So that is 16,000 feet. We then have our percentage increase or decrease. So this is a percentage decrease, so it is going down by 8% per minute. And the time scale, or the number of times, is just basically, in this case, it's not how many years, it's not how many days, it's how many minutes, because it is the percentage decrease is 8% per minute, and we're asked after how many, after 3 minutes. So the number of times we are doing the decrease is just 3 times. Okay, so remember the only real bit of work in here is to figure out that multiplier as a decimal for a decrease of 8%, and then you're just putting it into the formula. So our multiplier for a decrease this time of 8%. So we're going to start the same way we did with appreciation. You just always start with 100%, but because it is a decrease, we are taking away 8%. So if you take away 8%, how much percentage would you be left with? Well, that's going to be 92%, which changing that to a decimal number by dividing by 100. So 92 divided by 100, put that into your calculator and it gives you 0.92. So that is your decimal multiplier, 0.92. So if you just times anything by 0.92, it would decrease it by 8%. But we don't want to just do it once, we want to do it 3 consecutive times. So our final height is going to be the initial quantity, 16,000, multiplied by our multiplier, 0.92, and that multiplier is to the power of how many times? So it's to the power of 3. So get your calculators now and carefully put in that calculation. Okay, and what you should get is 12,459.008 feet. Okay, let's look at another example. So example number 2 is about population. So we've got the population of lions in Africa is currently 15,000. It is decreasing by 7% every year. And how many years will the population have halved in size? Now this is slightly different to the last one because we're not actually told how many years to do it over, how many times to do the reduction. What we have to do is work out what is half of this population, and then we're just going to have to keep on reducing it by 7% until it gets beyond that half. So first of all, the initial quantity, or the initial population, we should maybe say, is going to be 15,000. So half of this is 15,000 divided by 2, which is 7,500. Okay, so that's our kind of our goal, is to get this below 7,500 and then to figure out how many times that happens. The percentage is a decrease of 7%, so it's going down by 7%. So that is 100 take away 7, which is 93%. Yeah, so there'll be 93% left. So that as a decimal multiplier is going to be 0.93, because 93 divided by 100. Okay, and we don't actually know how many times we have to do it yet. That's what we have to figure out. So basically, we're going to have to do, after year 1, the population is going to be 15,000 times 0.93. So what is that value? So it's a kind of trial and error. We're just going to have to keep on doing this until we get below that 7,500. So after year 1, it goes down by 7%. It's 13,950. So after year 2, the population is now 13,950, and we're going to times it by 0.93. So we're just going to keep on doing this until we get below 7,500. So if you've already got that in your calculator, you don't even need to retype it in. You just hit times 0.93, and that gives you 12,973.5. So after year 3, it's 12,973.5 times 0.93 again. So answer, hit equals, that decreases it again. Okay, and if we keep going, so we do it, this might take us a wee while, so we can actually just keep hitting equals and we'll get there. So 4th time, we're at 11,220. 5th time, 10,435. 6th, 9,704. 7th time, 9,025. 8th time, 8,393. 9th time, 7,806. 10th time, we actually get down to below our value of 7,259. So all I was doing there was just actually hitting equals, answer times 0.93, hitting equals, and each one of those counts as kind of 1 year, and then just count how many it takes. So after 10 years, after year 10, that would be how long the population is halved in size. Okay, so really this second example is a more kind of problem solving one. What you are most often going to have is will be given the number of times, so you just need to get your initial population, just need to get your multiplier, and then to the power of number of times. Okay, that's going to be the most common question, but you may be asked some other questions like this where you need to do a wee bit of trial and error.